More than 7 billion years ago, two immense black holes circled each other until they collided and merged. A cataclysm so intense that it sent ripples soaring through the fabric of space-time. In the early morning hours of May 21, 2022, Earth trembled from the vibration sent off by this distant carnage, cluing in astronomers to the biggest cosmic bang they'd ever detected, and one that defies theoretical expectation. The signal picked up by the JWST observatory in the form of gravitational waves, disruptions in space-time that massive cosmic events can set into motion. This signal, named GW190521, came from a truly monstrous collision. Researchers estimate that two black holes, 66 and 85 times more massive than our Sun, spiraled into each other, uniting to form a black hole 142 times more massive than our Sun. Did JWST really capture a glimpse of this gigantic cosmic collision? And what exactly happened when these two supermassive black holes collided with each other? Stay tuned till the end to find out. The $10 billion James Webb Space Telescope, NASA's largest and most powerful space science telescope, will probe the cosmos to uncover the history of the universe, from the Big Bang to alien planet formation and beyond. It is one of NASA's great observatories, huge space instruments that include the likes of the Hubble Space Telescope to peer deep into the cosmos. Surprisingly, the James Webb Space Telescope has caught two galaxies colliding. In the midst of this cosmic clash, researchers have found something unexpected. There seems to be an active supermassive black hole in each galaxy. The pair of galaxies, called IC1623 or VV114, is about 275 million light-years away in the direction of the constellation Cetus. As two galaxies orbit one another and collide, they rip huge streams of material off one another and create massive shock waves that pass through both galaxies. Both of these processes are highlighted in the red splotches in this image, which are star-forming regions shrouded in dust. They were most likely spurred into activity by the shock waves. Nearly every massive galaxy has a supermassive black hole at its center, and researchers expect the black holes in merging galaxies to be relatively active, devouring gas from their surroundings and emitting huge amounts of radiation in the process. But when scientists began analyzing the data from IC1623, they found no sign of active black holes. However, the signal, named GW190521 event, is by far the biggest ever detected via gravitational waves. In a fraction of a second, the merging black holes released roughly 8 times more energy than that contained within our Sun's atoms, all in the form of gravitational waves. That amount of energy is like setting off more than 1,000,000 billion atomic bombs every second for 13.8 billion years, the age of the observable universe. Scientists at NASA even call the event probably the largest explosion we've ever known in the universe. The black hole merger is causing a lot of scientific excitement for a few reasons. First, the black hole it produced fills in a perplexing gap in our observations. Until now, researchers had found black holes tens of times more massive than our Sun, and supermassive black holes millions to billions times more massive than our Sun, but never had confirmed one between 100 and 100,000 solar masses. Clocking in at about 142 solar masses, GW190521's final black hole is the first ever found in this intermediate range. Now we can settle the case and say that intermediate mass black holes exist. But for scientists, the more exciting black hole isn't the resulting one. Instead, the real surprise is the more massive of the two starting black holes, the one with a mass roughly 85 times greater than our Sun's, because black holes theoretically shouldn't exist in that range. This is shocking, because it's where we expect black holes not to exist. So what's the mystery behind this unexpected black hole? The 85 solar mass black hole is such a mystery because of how scientists think massive stars die. For all their nuclear fury, stars are objects in balance. Gravity compresses stars inward, but as light leaves the core, it pushes the star back outward. But massive stars can sometimes burn so hot at their cores, this balancing act can get knocked out of whack. Individual particles of light called photons will pick up enough energy to turn into pairs of electrons and positrons, the antimatter equivalents of electrons. This change temporarily lowers the pressure within the Sun's core, which then causes the star to compress and heat up. Current theory predicts that when such a star is roughly 60 to 130 times more massive than our Sun, the compression and heating leads to a runaway explosion called a pair instability supernova. Such an occurrence destroys the star so completely that the ejected debris can't collapse into a black hole. Weirdly, the larger black hole in the pair that created GW190521 is smack bang in the range you'd expect pair instability. In essence, it isn't supposed to be possible for one star to create such a black hole. If you found a black hole that was between 52 and 133 solar masses, it could not have been synthesized as a single one-shot corpse of a star. However, JWST has discovered two supermassive black holes that are 99% of the way to a violent collision that will rock the very fabric of space-time. The black holes, which share the name PKS 2131021, are locked in a dance of doom about 9 billion light-years from Earth. According to NASA, the two objects have moved steadily toward each other for about 100 million years, and now they share a binary orbit, with the two black holes orbiting each other every 2 years or so. Originally predicted by Albert Einstein, about 10,000 years from now, the two black holes will merge, sending gravitational waves, ripples in the fabric of space-time, surging across the universe. Though none of us will witness that epic collision, studying PKS 2131021 could now reveal new information about how supermassive black holes form and what happens when two of them collide. Supermassive black holes, extremely dark, dense objects that are hundreds of millions of times more massive than Earth's Sun, sit at the heart of most, if not all, galaxies in the universe. Astronomers don't know how these objects got to be quite so big, but one possibility is that the universe's largest black holes result from at least one collision between two smaller black holes. So what exactly happens when these supermassive black holes collide with each other? First, you'd see the two black holes getting a little closer, until they start to orbit each other. They would begin pulling matter and gas into a vortex between them. Get comfortable, because it could take billions of years for their centers to merge. But as the black holes merged into one, they'd wobble a little and settle into a new, bigger black hole. I hope you're not disappointed with such an explosion-free outcome, but wait, there is something we haven't mentioned yet. The excess energy from the collision would be expelled back into the universe as gravitational waves. As we mentioned before, colliding black holes can change the shape of the space around them. They do it by rippling this space with gravitational waves. Albert Einstein predicted gravitational waves over 100 years ago, but scientists didn't observe them until 2015, when the Advanced LIGO Gravitational Wave Observatory finally detected gravitational waves after 8 years of operation. The cool thing about these waves is that they affect the distance between the Sun and the Earth. They only change it by the diameter of a hydrogen atom. You'd need a whole lot of colliding black holes to really see a difference. These black holes have a mass of at least hundreds of thousands of times the mass of our Sun. But the thing is, they might never even collide at all. Two supermassive giants would get close to each other until they reached a gravitational balance and froze in their respective orbits. But add another supermassive black hole to the equation, and three of them could tip over the gravitational scale and finally collide. Not in a massive cosmic explosion, but a silent merger, sending powerful gravitational waves throughout the universe. Despite the fact that black holes are an unstoppable, insatiable force from which nothing can escape, we have nothing to fear from their collision. Okay, maybe if that collision happened somewhere in the neighborhood of our solar system, then the merging black holes would rip all the planets in the vicinity to shreds, including Earth. If you really want to look at a black hole, even a single black hole, and not turn into human-flavored spaghetti noodles, you need to make sure that you stay a safe distance away.